So welcome back. This is my third video on a double integral. Okay, so let's get started. So evaluate the following double integral. Okay, so we are given the limits of integration here, as well as we are given the function, which is the integrand. All right, so now, first of all, let us identify the region of integration. Okay, how does it look? Is it a circle? Is it just planes and all that? Okay, so you notice that because if you're able to identify that, you know now which coordinate system you're going to deal with. You're going to solve the problem in. So whether it be cylindrical, spherical, polar, and all that. So if you're talking about double integral, we're going to talk about either polar coordinate system or rectangular coordinate system. So if it's polar coordinate system, the region of integration may be part of a circle, or it should be a circle, of course. Okay. So we need to do the conversions from rectangular to polar. So let's look at these limits here. So notice that the outermost limits here are limits in the x. So x runs from -1 to +1. Okay, so let me just draw the xy plane. So x-axis here, y-axis. So x runs from -1 to 1. Okay, so the boundaries for x. While y runs from 0 to square root of 1 minus x squared. Okay, so I don't know what exact value it is, but the values of y are dependent on this function, isn't it? So it means that y is varying as x varies, right? So y runs from 0. So y is equal to 0 with the x-axis to y is equal to root 1 minus x squared. So, okay, so root 1 minus x squared, that's just be y squared equal to 1 minus x squared. So this is the same as that x squared plus y squared is equal to 1. Okay, so this means that we have a semicircle, isn't it? Because we are from 0 to 1 as the values of y. So it means that you have a semicircle. So you have a circle that goes up to here. So with a radius of 1. Okay, so that's a semicircle we have. So now I've seen that, okay, our original integration is simply what? A circle. Okay, so we have to deal with this problem in what? Polar coordinate system. Okay, so now what do we do? So we have to find the limits for this circle. Here, remember that the positive x-axis is at 0 radians or 0 degrees, and then y-axis of pi over 2 pi is 3 pi over 2 until add 2 pi, right? So the full evolution is simply what? 0 to 2 pi. Now you notice that for this circle we are starting, remember we measure from counterclockwise. So from 0 degrees to 180 degrees. That's the region the circle is covering, right? So from 0 to pi, those will be limits for theta. So theta will range from 0 to pi, or the radius just between 0 and 1, right? So radius just be minimum value of radius simply 0 to 1. And of course, a radius is always positive. So can't have a negative value. Alright, you can't say radius from -1 to +1. No. Okay, you say radius between 0 and 1. So 0, let's go to r, let's go to 1. Okay, so those will be our new limits. So I've managed to convert the limits, these Cartesian limits to polar limits. Okay, so limits for theta from 0 to pi, limits for r from 0 to 1. What else? Okay, we have to convert this part here. So x squared plus y squared is square root. We have to convert it. So but remember that x squared plus y squared in polar is simply equal to r squared, right? Okay, so in place of x squared plus y squared, we'll replace it with r squared. So square root of r, square root of r squared. And then what else are we supposed to convert? Dy dx. Dy dx in polar is given as what? R d theta. Okay, so now I've managed to convert everything from cylindrical to polar. So we can take a square root of r squared, that just be r from 0 to pi, 0 to 1. This is r squared. Why r squared? You have this r here and this other r here. So you get r squared. And then r d theta. We integrate straight to r. What do you get? So from 0 to pi, the integral of r squared is simply r cubed over 3, limits from 0 to 1 d theta. Okay, so let's substitute the limits. The upper limit of r is simply 1. So from 0 to pi, the upper limit of r is 1, so 1 cubed over 3 minus the lower limit is simply 0, so 0 cubed over 3 is theta. So 0 cubed over 3 is just equal to 0. So we just have integral from 0 to pi 1 over 3 d theta. And if we integrate 1 over 3 d theta, we just have 1 over 3 theta. Limits from 0 to pi. Substitute the upper limit. The upper limit is simply pi minus the lower limit is simply 0. So our final answer becomes 1 over 3 pi. Okay, so that's the final answer. Thank you for your attention. Please, more content is coming. Just be around. Keep checking. Okay, and subscribe. Don't forget to subscribe, share with your friends, and also comment in case any suggestion or any topics if you people want to see on my channel. You can let me know. Thank you so much.